All right, so now let's just look at the kind of thing you'll be expected to do with this. This is chapter 6, page 328, number 48. They give you dy dx equals x minus 2y. The point is 2, 1. And we are to estimate, yes, cat. We're to estimate y of 1.7 using delta x equals negative 0.1. All right, so one of the things you can do, with these things is you can use a negative delta x. So what that means is, if I look at my original point 2, 1, 2, 1, right? So instead of tracing points going this way, we're going to trace points going back this way, and we're going to find a point back here, 1.7. Right, so we're tracing back from the point instead of moving forward from the point. That's why we're estimating a value that is lower than the x value that I already had, so my x value is dropped, by using a delta x of negative 0.1 means we're working backward from the point instead of forward. But it does not change anything at all about the math. So you lay out a table. We got the point x, y. We got dy dx equals x minus 2y. We got delta x. We got delta y equals dy dx. You'll be glad to know I only had you do 4 of these. Dy dx delta x, and then we have x plus delta x. Oops, that's an x. Y plus delta y. All right, so that's our basic layout of our table. All right, so your first point is the first point, 2, 1. So we start with 2, 1. All right, we do x minus 2y, so I'm going to do 2 minus 2 times 2 is 0. All right, my delta x is negative 0.1. I can go ahead and fill in some things. All the delta x's are negative 0.1. All right, so my delta y is dy dx, so I just multiply dy dx times delta x, I get 0. My x plus delta x, so I'm going to take my 2, and I'm going to add negative 0.1 to it. I'm going to get 1.9. And I'm going to take my y coordinate 1, and I'm going to add 0 to it and get 1. Right. The other thing I can do is the delta x is always going to create an arithmetic progression of my x's. So it's going to go 1.8, 1.9, 1.8, 1.7. And then I also, I'm looking ahead to know when I get to 1.7, I'm done. So that's a nice way, lay that out so you know how many you've got to do. I mean, obviously there are other ways to do that. All right, now I take this point that I have here, I pull it over here, 1.9, comma 1. Yeah. And then I do 1.9 minus 2 times 1. That's 1.9 minus 2, so that's negative 0.1. So you haven't even reached for a calculator yet. Then we've got 0.01. All right, so then now I've got to I've already did my x plus delta x. I got to do y plus delta y. So here's my y. Here's my delta y. I do 1 plus 0.01. Don't need a calculator for that either. It's 1.01. Right, so I bring that down as my next point. So now 1.8, 1.01 is my next point, 1.8, 1.01. So now I have to do 1.8 minus 2 times 1.01, 1.8 minus 2.02. Well, I might reach for a calculator on that one, which I did, in fact, and I get negative 0.22. Negative 0.22 times negative 0.1 is certainly 0.022. And then when I add those together, add my y to my delta y, right? Y plus delta y, so y plus delta y is 1.032. Now, since I've already got the y.7, I've already answered the question. I say y of 1.7 is approximately equal to 1.23. All right, there's your estimate. It's not very good. I did a fun thing. I put the, so an interesting thing is that you can't solve this analytically. I'm sorry, you can't solve this analytically with the methods we've learned here. So if you take differential equations, you'll learn how to solve them. I threw it into my old friend Wolfram Alpha, who does, basically anything mathematical. And Wolfram Alpha came up with this solution: y of x equals c1 e to the negative 2x plus x over 2 minus 1/4. I kind of almost remember how to do that, but not really. I solved for the c, and I got c equals e to the 4th over 4 using my 0.21. So I ended up with the equation y equals e to the 4 minus 2x over 4 plus x over 2 minus 1/4. And then I used that to find out what y of 1.7 really is, and it's 1.055. 1.055. Oh, I'm sorry, this is supposed to be, I totally wrote that wrong. It's 1.032. Right, that's what I had right there. I don't know where I got that. 1.032, okay? But you can see it's not a very good estimate. So Euler's method, the reason it's not very accurate is essentially it's a first order linear method. So we're using linear approximations, and then every step we take would compound the errors of the previous step. We're using what, mathematically are considered huge delta x's. That's so that you can compute this by hand and it makes sense. But you could see that you could pretty easily write a computer program to do this using delta x equals negative 0.001, and you have much more accurate result. You can try that if you're into that sort of thing. All right, so there you go. That is Euler's method. Here is your homework on Euler's method. It is from chapter 6, page 321, 328, number 41 through 47, odd, a mere 4 problems, but they are 4 problems of this order of computational intensity. But that's fine. You can handle it because you're BC. All right, enjoy.